This is Industrial Electronic Devices. This video is on integrated circuits and is the first part, Introduction and Handling. All the electronic components covered to this point have been individually packaged devices that are connected with other individual devices to form a functioning unit. These individually packaged devices are referred to as discrete components. The problem with discrete devices is the amount of individual power consumed, not to mention the amount of space they require. But due to miniaturization, we can now put billions of transistors into smaller and smaller packages called integrated circuits and RISC chips. This lesson introduces integrated circuits, or ICs, in which many diodes, transistors, capacitors, and resistors are built into tiny chips and are packaged in a single case to form an operational circuit. After completing this lesson, you should be able to describe an integrated circuit and explain the storage and care of handling of an integrated circuit. Integrated circuits can contain a few to millions of components and are efficient. Many perform fixed functions, for example, counters and timers, etc., and can act as a building block for larger, more complex systems. One example of a standard IC is the three-component IC. It combines a diode, a transistor, and a resistor. The diode controls the current direction, the transistor controls the flow, and the resistor limits the voltage to the collector. Most IC packages that we will be working with are what they call dual inline packages, or DIP. The 741 op amp. There's a lot of information that can be determined by carefully examining the IC itself. All ICs are polarized, and it is vital to determine the pinout so the IC will function and not be destroyed. With all of the components built into each IC, the proper storage, care, and installation must be followed. Static electricity is the enemy of ICs. Static electricity can generate enough voltage and current to destroy them. Many electronic components use the metal chassis as a reference. A grounding strap dissipates any static charge you may have or developed. Wristbands adjust to varying sizes. Self-coiling grounding cords grants freedom of movement and freedom from tangles. An integrated 1 meg resistor for safe dissipation of static charges is included. Removal of faulty ICs should be done with care. It is preferable to use a proper extraction tool. If you don't have one, you can use a small screwdriver to loosen the IC and then pull it straight up. The pins can be bent very easily, and you risk damaging the socket or the circuit board. When installing a new or replacement IC chip, be sure to align the chip and socket notch to notch. Then set the IC in, making sure each pin is aligned prior to pressure. Once this is done, press straight down firmly. In our next video, we will look at the testing method used when working with IC chips.